Welcome to our video on the Hubble Telescope, one of the most technologically advanced pieces of equipment that humans have put into orbit. Before we begin discussing the Hubble Telescope's design choices and how it functions, we would first like to give a brief history on the Hubble Telescope. The story of the Hubble Telescope begins with American physicist Lyman Spitzer, who proposed a complex plan for a space telescope in 1946. However, Lyman lobbied for his idea for almost 30 years before it actually came to fruition. In the 1970s, NASA and the European Space Agency took up the idea and proposed a 3-meter space telescope. Funding began to flow in 1977, and it was decided to name the telescope after Edwin Powell Hubble, the man who had discovered the expansion of the universe in the 1920s. Although the Hubble Space Telescope was downsized to 2.4 meters, the project started to attract significant attention from astronomers. The assembly of the entire Hubble Telescope spacecraft was completed in 1985 and was launched in 1990 with tension built up as astronomers examined the first images through the Hubble's eyes. Unfortunately, it did not take long to realize that Hubble's mirror had a serious flaw that prevented it from taking sharp images. The mirror edge was too flat by a mere 50th of the width of a human hair. A crew of astronauts carried out the repairs necessary to restore the telescope to its intended level of performance during the first Hubble servicing mission. In December of 1993, since SMI, 4 other servicing missions have been carried out. During SM2 in 1997, 2 new instruments were installed. Servicing mission 3 was split into 2, leading to a significantly confusing numbering system. In SM3A in 1993, many of the Hubble's crucial technical systems were exchanged, and in 2002 came SM3B, when the Hubble again got new science instruments. Servicing Mission 4 took place in spring of 2009. During SM4, astronauts upgraded the Hubble's scientific capabilities again, installing a new main camera and an instrument designed to help answer profound questions about the large-scale structure and origins of the cosmos. With the retirement of the U.S. Space Shuttle in 2011, no further servicing missions will be possible. However, with the telescope fully repaired and upgraded, it is expected to function well for around 7 to 8 years longer.
The Hubble telescope is about the length of a large school bus and weighs as much as 2 adult elephants. The Hubble travels about 5 miles per second, which is like traveling from the eastern coast of the United States to the western coast in 10 minutes. The Hubble is also solar powered because it's the most cost-effective and efficient method of power for its due to positioning to the sun. As the Hubble orbits Earth, the fine guidance sensors lock onto stars. The fine guidance sensors are part of the pointing control system and aim the Hubble in the right direction.
The Hubble telescope has 5 scientific instruments, which include cameras and spectrographs, which split light into its individual wavelengths. The Wide Field Camera 3 is the Hubble's main camera. The camera can see 3 different kinds of light: near, ultraviolet, visible, and near infrared. The Advanced Camera for surveys capture images of large areas of space. These images have helped scientists study some of the earliest activities in the universe. The Cosmic Origin spectrographs read ultraviolet lights. This spectrograph studies how galaxies, stars, and planets formed and changed. The Space Telescope imaging spectrographs help scientists determine the temperature, chemical composition, density, and motion of the objects in space. It also has been used to detect black holes. The Near-Infrared Camera and Multi-Object Spectrometer, or NICMOS, sees objects in deep space by sensing the heat they emit. It captures images, and it is also a spectrograph. NICMOS helps scientists study how stars, galaxies, and planetary systems form.
For its time in the 1990s, the Hubble telescope was seen as the best option for the desired outcome of taking sharp pictures of objects in the sky, such as planets, stars, and galaxies. The Hubble has made more than 1 million observations in its time in space. These include detailed pictures of the birth and death of stars, galaxies billions of light years away, in comet pieces crashing into Jupiter's atmosphere. Today, spacecraft telescopes such as the JWST do outperform the Hubble telescope in almost every capacity, but we will always fondly look back on the Hubble telescope as the strongest of early spacecraft telescopes.